Here we go. Lesson 2, reference angles and the cast rule. And Kayvon, this is good practice for the question you asked me. I said, sketch the following angles and then on your calculator find their sine, cosine, and tangent. So first of all, let's sketch these angles. 50 degrees. What would that look like? We always start in standard position, which is positive x-axis. Don't write this down. If I go that far, how far am I? Too far. So 50 degrees, about like that, yes? And let's put a little 50 degrees there. Put the phone away, Christina. In your bright neon green case that makes it staggeringly obvious when you're holding it. Nice try. Christina, B, what's the next angle they want me to draw? Where's that going to be? Past 90? Yes? Okay, because if you go over here, how far is it? 180, that's too far, right? Okay, so you know what? Yoink. About there-ish, give or take. $230 degrees. Where would that be? Further? Further? Oh, good. I heard somebody say a little bit further. Yeah, I think somewhere in there, right? What about 310 degrees? I think about, because 360 is all the way around and 270 is right here, so a little bit past 270. Yes? Here is 310 degrees. So that was the first thing I said. And then I said, go back and for each of these find sine, cosine, and tangent. So let's start with the 50. Get your calculators out. And can you find for me sine of 50 degrees, cosine of 50 degrees, and then tangent of 50 degrees, and give them to me to 4 decimal places, let's say. What's the sine of 50 to 4 decimal places? Anyone? 0.7660? What's the cosine of 50 degrees? And I'm hoping you guys all know how to do this now, right? So cos 50, what is it? 0.6427? 0.6428. And what's the tangent of 50 degrees? 1.191? 8? All right. Can you find now the sine of 130, the cos of 130, and the tan of 130? And behold, I'm going to amaze you because I'm going to do it in my head. Am I right? Try this, please, on your calculator. Is the sine of 130 0.7660? No or yeah? Yeah. Yeah. Is the cosine of 130 negative 0.6428? Is the tangent of 130 negative 1.1918? Yeah? Hey, let's find the sine and the cosine and the tangent of 230. And I'm going to tell you that it's negative 0.7660, doing it in my head. I'm going to tell you that the cosine, try this, check me if I'm wrong, of 230 is negative 0.6428, doing it in my head. And I'm going to tell you that the tangent of 230 degrees is positive 1.1918. Am I right? You guys should be impressed. More impressed than just that. Come on, I'm doing like witchcraft.
Wow.
That's it. Is that right? Yes? Oh, and you know what? Let's find the sine, cosine, and tangent of 310. I think you'll find it's negative 0.7660. It's positive 310. It's positive 0.6428, and it's negative, double check me, 1.1918. Trying it? Yes? Am I right? People are typing this in, trying this, confirming? Seb is nodding. First of all, what do you notice about the decimal values of sine for all four of these? The decimal portion is the same. What do you notice about the decimal value of cosine for all of these? The same. And what about the decimal value for tangent of all of these? Okay. The positive or negatives, I'm going to say the signs are different, but I don't mean the signs like sine, cos, and tan. I mean the plus or minus signs are different, but the decimal portions are the same. What do all four angles have in common? Because I made this up pretty easily, it turns out. I can do this in my head, and it's an easy trick. You ready? Look up. Put your pencils down for a second and look up. How many degrees from here to here? Tell me. 50. Look up. How many degrees from there to there? Look up. How many degrees from there to there? Look up. How many degrees from here to here? What do all four of these angles have in common? If you drop down to the closest x-axis or move up to the closest x-axis, they have the same angle. In fact, we give this angle a special name where it says, what do all four angles have in common? They have the same reference angle. What's the reference angle? It's the angle measured to the closest x-axis. So can you draw in those 50s? Can you draw in those 50s? Roy, when we're talking about reference angles, if you have an angle here, or here, or here, or here, that's the reference angle, that's the reference angle, that's the reference angle, or that's the reference angle. It's measured to the closest x-axis. It's always positive. Yep. Let me pause for 1 second. That is hugely profound. Here's what that means. It means, with a bit of cleverness, it turns out, Rachel, all I need are the sine, cosine, and tangent values between 0 and 90. That's going to give me the decimals. If I can figure out the plus or minus sign, I don't need the rest. I can figure that out. Next page. Sketch the following angles I wrote and then find their sine, cosine, and tangents. We're going to try and do this only partly with a calculator, and then we're going to try and do the rest in our heads. First of all, let's do the sketches. So 75 degrees, that's going to be about there. What about 105? How far? About there? Because that's 90, 15 past 90. By the way, if this is 105 degrees, how big is that angle? 75. It's got the same reference angle as the first, as A. I did this on purpose when I made these up. 255 degrees, well, how far right to there? 180. How much further than 180 do I need to go to get to 255? And you can use your calculator or you can do the arithmetic in your head, but how much further? Turns out 180 plus 75. That's why I picked 255 there. 285. How far is that? Well, how far is 3/4 around? 270. How much further than 270 am I going? 15 degrees further. How big is this angle here, the reference angle? 75. All four of these, Sean, have the same reference angle. which means all of these are going to have the same decimal values for sine and cosine and tangent. It's just that the positives and negatives are going to be different. Can you, on your calculators, folks, tell me the sine of 75 degrees and give it to me to 4 decimal places? What's the sine of 75? Folks? Christina? Brooke? I need you guys here. Sorry, what was that, Colin? 9659? Is that right? What's the cosine of 75? Anybody? Can't be taking this long. Type it into your calculator. If you don't have your calculator in your hand, you're not following along. Not that I'm mentioning any names in the back row there. Yeah, you! Sorry, what is it? 0.2588. Is that right, folks? Okay, and what's the tangent of 75? 3 point, what, Brooke? 732? Anybody else? Yeah? Okay. I'm going to tell you, and you guys can double check me, I know that in quadrant 2, in this quadrant here, I know that cosine and tangent are negative, which means the sine of 105 is positive 0.9659. Can you check that really quickly, please? I'm telling you the cosine of 105 is going to be negative 0.2588. Can you check that, please? And the tangent of 105 is going to be negative 3.732. Double check me, but I think I'm right, yes? Yeah. You don't know yet. I haven't taught you yet. I'm telling you I know, and in about 15 minutes you'll know. Patience, young grasshopper. Great question. I'm glad you asked. And there's going to be, turns out, an easy little acronym we're going to memorize. It's called the CAST rule. In quadrant 3, bottom left there, I know that in bottom left, tangent is positive, sine and cosine are negative. I know that sine of 255 is going to be negative 0.9659. Double check me. I know that cosine of 255 is going to be negative 0.2588. Please double check me. I know that the tangent of 255 is positive 3.732. Brooke, I haven't told you yet how I know, but it's an easy trick. And hopefully you can see I'm doing this almost absent-mindedly. It's that easy a trick that I'm not really having to concentrate here. Is that right, though? Yes, you type in the numbers and you get those answers? I know that in the bottom right quadrant, in quadrant 4, cosine is positive. I know that. Which means sine of 285 is going to be negative what? Because they have the same reference angle. Cosine is positive, so it's going to be positive 0.2588. I know that tangent, by the way, Brooke, technically you know already as well, you just don't know that you know, is negative 3.732. Okay? What do you notice? I hope you saw, Rosanna, the decimals are all the same. They all have the same sine decimal. They all have the same cosine decimal. They all have the same tangent decimal. What do they have in common? That 75. And what did we call that 75? Begins with the letter R, key term today. So they all have the same reference angle. The reason we call it a reference angle is, if I know that angles have the same reference angle, I can use the first one as a reference and get the rest of the decimals. This is hugely helpful. You don't know that yet, but it is. Okay? So, Connor, first concept, angles that have the same reference angle will have the same decimal value for sine and for cosine and for tangent. One might be positive, one might be negative, and Brooke's going to learn a trick in a second on how to figure that out. Next page. It says, sketch the rotation angle and then state the reference angle. Okay. 120 degrees, where's that going to be? Guys with me? Okay, 120 degrees is about there. We've turned the page. You know what? My abbreviation for reference angle is capital R and then a little theta as my angle variable. So the reference angle is, this is the reference angle right there. Do the arithmetic. How big must it be? I've heard 70, I've heard 60. Which one? How do you figure it out? All the way is what? 180. And 120, what's left? 60. Okay? B. Oh, and until you get very good, the easiest way to find the reference angle is to do this 1 second sketch. B, 251 degrees. Okay. How far have I just drawn? 90. How far have I just drawn? 180. Do I want to go to the next line? No, that's 270. So 251 degrees is right about there. Now, how big is the reference angle? Remember, it's that. How can I figure that out this time?
270 minus 251.
No, 270 minus 251 would give you that angle. I don't want that angle.
251 minus 180.
Jordan.
251 minus 180.
Okay, 180 is right here. I went a little further. How much further? 251 minus 180 because I want this one, right? Okay. What is 251 minus 180? 71 degrees. Okay. By the way, the first suggestion you made is a common mistake. Don't do that. Kids want to find, oh, it's just always to the closest line. No, it's to the closest x-axis, which means almost always you're going to be dealing with 180 degrees. Oh, C, 339 degrees. Any thoughts on what we should do first here? Dolp. Physics, dolp. Sketch, absolutely. Can't do these. Honestly, I can't do these in my head. I gotta see it. So, Colin, you ready? How far? Colin, how far? How far? How far? If I go all the way, how far? Do I want to go all the way? Nope. I want to stop there. But the reason I asked that, because this is what I want to find, how can I find the reference angle for 339 degrees? No, that's going to give you this one again. Ready, Colin? What? I think you're thinking it right and saying it wrong. 360 minus that, okay? 360 minus 339, which is what? 21. D. What am I going to do first? Dolp. Kyla, 74 degrees. How am I going to draw that, kiddo? Kyla, look up. How far? You're right. What'd you say? Good. Too far? Okay. You know what? I think 74 degrees, this is the easiest reference angle to find. Anything in quadrant 1 automatically is its own reference angle because that's the closest x-axis. So what's the reference angle? How big is that angle right there? And this is why, by the way, you never had to pay attention to reference angles in Math 10 or Math 11 because in your triangles, you were always staying between 0 and 90. And so actually what your calculators were dealing with all the time was the reference angle. So we never had to mention it. It's when we go beyond 90 degrees that things get weird. E. Jake, my friend, what's the angle that they gave me?
Negative 199.
Any suggestions on what I want to do first? Yes. Yeah, sketch. And you said, did you say drop backward? Yeah, negative means go. Okay, so ready? How far? Don't say 90.
No. 90.
No, don't say 90. Negative 90, yes? How far? Negative 180? How far if I go to the next line? Negative 270. Too far? Negative 199 is right about there. Now, the reference angle is that guy there. How big? Now, I'm going to give you a hint, Jacob. By definition, reference angles are always positive. Even if you're starting out by drawing it negatively, reference angles are positive. So give me the positive size of that little red angle there. Can you see it, folks? Jordan, 19, right? 180, 190, 19. Okay, you're going to be finding a whole bunch of reference angles. You want to get good enough that this becomes almost boring in your sleep-ish. So we're going to practice this a lot. Let's do one more. Justin, let's do F together, shall we? Yeah. What am I going to do first? Darn right. Might even hand in some homework while I'm at it. Let's keep going. Ready, Justin? Positive or negative?
Positive.
Okay, so we're going this way. How far?
Farther.
How far exactly?
180.
No. How far did I just draw? 90. How far?
90. 180.
How far? Because this is a big one. We got to keep counting.
270.
How far?
360.
How far?
460. I don't know.
It's your 9 times table. So after 36, 360 comes what? 450, 45.
Yeah.
How much further to get to 463? Just a little bit. Right? So here's my question. How big is that angle? Because that's the reference angle. Now, if you're having a tough time spotting this, if you want a mathematical way, I guess what you could do is find the principal angle. Kayvon, how do I find the principal angle? Remember we talked about this earlier? So if you want to get it to a smaller, more manageable version, you could go 463 minus 360. That's the same angle, so this is also 103 degrees. How far all the way over to there? 180. I'm at 103. What's left here? Unfortunately, Rosanna, I can't give you one rule to fit them all. There is no one rule, here's how you find a reference angle. All I can say, Cole, is draw a sketch, color in what you're looking for, and then add or subtract as necessary. It's going to depend what quadrant you're in and how big your original angle is. I can also reverse, instead of giving you the original angle, yeah. Okay. 2 ways. First of all, this is 450 degrees. Just look up for a bit. This is 450 degrees. How much further do you go right there to get to 463? 13. So what's left over to fill the 90? That's one way. Or the other way that we did it, as I said, if you don't like the big angle, you can find the principal angle, which is 103, and that's a little easier to visualize. 103, how much further to get to 180? 77. Is that okay? I can, Rachel, also do this backwards. Instead of giving you the angle and saying, hey, what quadrant, find the reference angle, I can give you the reference angle, say what quadrant, tell me the original. So this first one here. Roy, let's do a sketch. What quadrant do they say that we're in, Roy? So I just do kind of a generic angle, yoink, right there. What's the reference angle that they gave me? So this angle right here is 29 degrees because the reference angle is measured to the x-axis. All right, folks, this is the angle that I want. How big? Okay, 180. There's going to be a different rule depending on what quadrant you're in. So unfortunately, I can't say, here's the one-size-fits-all rule. Ellen, all I can say, draw a picture, and then this is why, by the way, from day one, I've been saying, how far? 180. How far? 270. How far? 90. I'm trying to get you used to moving around this circle. What did you say it was, Jordan? 180? Okay. 151 is in quadrant 2 and has a reference angle of 29 degrees. Or if I'm in quadrant 2 and have a reference angle of 29 degrees, I must have moved 151 degrees from the principal. Next one. Sean, my friend, how big is the reference angle that they gave me?
64.
What quadrant? Let's draw a picture. So we're in quadrant 3, which is here. And they're telling me this angle is 64 degrees. I want that angle. How could I find that? 180 minus 64? 180 plus? Does that make sense? Yeah? 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 I can do that in my head. 244? Double check me. 244? Yeah? No? Yeah? If you're good at adding and subtracting arithmetic, these can be done in your head. On a test or a quiz, I always use my calculator because I don't want to make a mistake. But if you're trying to get good in your homework and you want to try doing some of these in your head, go ahead. Erica, what quadrant are we in for the next one? And it's got a reference angle of how big? That's quadrant 4. It's telling me this angle right here is 7 degrees. I want, that angle. Plus what? You just gave me a math. I need more specific. 360 minus 7? 7 less than 360? Erica, in your head, I think you can do that. 360 degrees, take away 7 is 353. Yep. It depends what quadrant you're in, okay? Look, how far from here to here? 180. How much further did I go? 64. That angle must be 180 plus 64. How far from here to here? Well, I didn't go all the way around. 360 is all the way around, but I went 7 degrees less than 360. So it's going to be 360 minus 7. I can't give you a rule. We just got to practice more of these. So can you hang on? I think it'll become clear, okay? The easiest one. So I'll give it to Kayvon. Kayvon, what quadrant are we in this next one? We're right here. What's the reference angle? And it's always measured from here, so that angle is 83 degrees. How big is that angle? Yeah. In quadrant 1, your reference angle is automatically your angle. Convenient. Ooh. Tiffany, where do you think between quadrant 3 and 4 is? You know what? Yeah, it's right there. So, how big? 270. Which also has a reference angle of 90 degrees. Okay? So if you give me a reference angle in a quadrant, I can find the principal angle. If you give me a principal angle, I can find the reference angle in the quadrant. Big deal. Huge deal. Now we're going to answer Brooke's earlier question. How was I able to tell in my head ahead of time whether sine or cosine was negative or positive? Whether tangent was negative or positive? Okay? Let's start in quadrant 1. Now, quadrant 1 is going to be right here. In that quad, you know what? Instead of drawing a squiggly line, let's do an angle. Okay? Here's sine, mystery angle. Here's our mystery angle. Here's cosine theta. Here's tangent theta. Sine is what over what in terms of x and y and r? Okay, it's y over r. Now, in this quadrant, that's the point x comma y, and that distance is r. If I'm in quadrant 1, my y-coordinate, is it positive or negative? Think about it. Am I above the x-axis or below the x-axis? So you know what? This is positive divided by positive. R is always positive because it's a length. In quadrant 1, sine is going to be positive. Let's compare that over here with quadrant 2. Sine is still y over r. In quadrant 2, am I above the x-axis or below the x-axis? So is y positive or negative? So in quadrant 2, it's still positive over positive. Where is sine going to be negative when the y-coordinate is below the x-axis? Let's look at quadrant 3. Down there. Sine theta is y over r, but what can you tell me about the y-coordinate down there? It's negative. R is always positive because r is a length. It's the radius. What's a negative divided by a positive? And what about quadrant 4? Well, sine is still y over r. It's still going to be negative divided by positive. Let's do the same thing for cosine. So by the way, it looks like sine is positive up top, negative down low. Okay. Cosine was what over what? X over r. Cosine is x over r. Cosine is x over r. Cosine is x over r. Right? In quadrant 1, is the x-coordinate, guys with me? Put the distraction away. In quadrant 1, is the x-coordinate positive or negative? This is still positive over positive. But look at quadrant 2. Now, quadrant 2, we're on the left side of the graph. Yes? On the left side of the graph, are my x-coordinates positive or negative if I'm on the left side of the graph? In this quadrant, it's going to be negative divided by positive. Cosine is going to be negative between 90 and 180. Cosine is negative. By the way, try it. What's the cosine of 110? You're going to get a negative answer, I guarantee it. Yes? I don't know what the decimal is, but it's negative. Yes? Cos of 110, negative. Sine of 110 will be positive because it's positive in that quadrant. Try me. Okay. What about this quadrant 3? Are we still to the left or are we still to the right? So it's still going to be a negative x divided by a positive r. You know what? I'll bet you the cosine of anything between 180 and 270 is negative. Try cos of 210. I bet you it's negative. Yes? What about quadrant 4? Okay, if I'm on this side of the right side of the graph, yes, my y is negative, but what can you tell me about my x-coordinate? Which means it's? I'll bet you the cosine between 270 and 360 is positive. Try cosine of 319. Guarantee you it's a positive answer. But the sine of 319, I'll bet you, is a negative answer. Yes? Let's do the same thing for tangent. Tangent is what over what? And Brooke, this is why I said technically you know this without knowing this, because you notice we're figuring it out by using x over r, y over r, and y over x, which you already knew those, but we hadn't thought about applying it to positives and negatives. So tangent is y over x. Tangent is y over x. Tangent is y over x, and tangent is y over x. In quadrant 1, is the y-coordinate positive or negative? Positive. What about the x-coordinate? In quadrant 1, positive over positive. This is why, by the way, you'll notice in quadrant 1 between 0 and 90, everything's positive. Silke, this is why you never ran into negative trig stuff in grade 10. Because in your triangles, you were never dealing with angles bigger than 90 degrees. Y-coordinate in quadrant 2, positive or negative? Positive, because we're above. What about the x-coordinate? This is positive over negative. What is a positive divided by a negative? Tangent's going to be negative between 90 and 180. Guarantee it. By the way, there's a way easier way to remember this. I'm deriving this with you, and then I'll show you the cheap and easy shortcut. Quadrant 3, y-coordinate, positive or negative? X-coordinate, positive or negative? In quadrant 3, it's negative divided by negative. What is a negative divided by a negative? So tangent between 90 and 180 should be positive. Hey, find the tan of 110. Bet you it's positive. Yeah? What about quadrant 4? Y is negative. X is positive. You have a negative divided by a positive, which is a... All right? We're going to memorize this, but we're not going to memorize this. We're going to make it simple. We're only going to ask which ones are positive where. In the bottom right, down here, which one's positive? All of you right now, please put a huge capital letter C right there. Which ones are positive in quadrant 1? How about a big A for all of them? Which ones are positive in quadrant 2? How about a big S for sine? Which ones are positive in quadrant 3? And we call this the cast rule, C-A-S-T. If you start on the bottom right. This is how I was able to do it in my head. I was just imagining a big cast. So a couple of questions ago, when we were sketching these and I was telling you whether they're negative or positive, I was literally going C-A-S-T in my head, and I could tell you which ones were positive. Oh, and then the rest are negative. Oh, and the reciprocal trig functions follow. So wherever tangent is negative, so is cotangent. Wherever sine is positive, so is, which one goes with sine? Cosecant. Okay. So you don't have to memorize another rule. So where is sine positive? Where is cosine positive? Where is tangent positive? And these can be memorized with the second best acronym in trig. If SOHCAHTOA is the first, CAST is the second. In fact, Connor, from now on, whenever I start to do a sketch, which I've been already doing on most of our questions, instinctively, I'm also going to do the cast rule right away. Even if I don't know if I'll need it or not, I'll stick it on. It takes 1 second. Oh, note, each reciprocal trig function follows its corresponding primary trig function. So, you know what? C-A-S-T. What does secant go with? So where is secant positive? Well, 1 and 4, right? Because all are positive in the first. Don't forget that one. What does cosecant go with? So where's cosecant positive? Quadrant 1 and quadrant 2. Where's cotangent positive? Quadrant 1, quadrant 3. This is hugely profound. The idea of reference angles and the cast rule means that the trig ratios of any angle can be written as the same trig function of the reference angle along with the positive or negative from the cast rule. Huh? Show you what I mean. What's the reference angle of 125 degrees. Sketch. C-A-S-T. $125 degrees, where's that? About there? What's the reference angle? Do the arithmetic. What's the reference angle? How can I figure it out? 180 minus 125. So what's the reference angle? 55 degrees. You're giggling about the enthusiasm of math? I hope so. So what does that mean? Okay. First of all, which trig functions are positive in this quadrant? Sine and what goes with sine? So, positive, negative, 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 positive, negative. It means that the sine of 125 is the same as positive sine of 55. Cosine of 125 is the same as negative cos of 55. Tangent of 125 is the same as negative tan of 55. Secant of 125 is the same as negative, excuse me as I cough, secant of 55. Cosecant of 125 is the same as positive cosecant of 125. And not 125, 55. And cotangent is the same as negative cotangent of 55 degrees. Look at this and realize how profound it is. It means that in the pre-calculator days when we did everything from charts, I didn't have to give somebody a chart of every single angle from negative infinity to positive infinity. I just gave them every angle between 0 and 90 and they could find the reference angle and find the positive or negative. Done. Piece of cake. Or, in all honesty, your calculators, I suspect, only have the values between 0 and 90 degrees programmed in and use some kind of an algorithm to find the reference angle and the sine. Ta-da! Next one. What's the reference angle of negative 115 degrees? I better sketch it. Jacob, back row, my friend. What does negative mean? Which way am I? Oh, hang on. I better put the cast rule in now, from now on. What does negative mean? Which way am I going? How far? How far is that?
90.
Don't say 90. It's not. Negative 90. If I went to the next line, how far would that be?
Negative 180.
Do I want to go that far? No, how far do I want to go? Negative 115 is about-ish there-ish, kind of ish there. Now, folks, you've got to be able to figure out how big this angle is. This is the reference angle right here. How big is it? How can I calculate it? Yeah, you know what? I'm going to go, again, to find a reference angle, because reference angles are positive. Now that I've sketched it, I ignore the negative. It's 180 minus 115. You guys hopefully found a reference angle was 65 degrees, yes? What does that mean? Well, it means that the sine of negative 115, the decimal will be the same as the sine of 65. The decimal will be the same as the cos of 65. The decimal will be the same as the tan of 65. The decimal will be the same as the secant of 65. The decimal will be the same as the cosecant of 65. The decimal will be the same as the cotangent of 65. But the plus or minuses will be different. How can I figure out the plus or minuses? Look what quadrant I'm in. Which ones will be positive? Tangent and negative negative, 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 positive in front of the other two, but I'm not going to bother putting a plus there. Sine of negative 115. Enter. Negative sine 65. Enter. The same value. Cosine of negative 115. Negative cosine of 65. The same value. Tangent of negative 115. This should be positive. Ha ha! It is. Tangent of 65. Oh, I did cos. Tangent of 65. Okay. Couple more, we're done. So, this says rewrite as the same trig function of a positive acute angle. Say what? It wants us to rewrite this the same way we rewrote these. So first thing I want to do is a sketch. I'll do that right there. I'll write the cast rule. What's the angle that they gave me? 140 degrees is about there. Positive or negative, first of all? Sine of 140, positive or negative? I'll put a positive. If you don't put a positive, I'll assume you're saying it's positive, but I'll just show it in our notes. What's the reference angle? Sorry, how big? 40 degrees. You know what? The sine of 140 is the same as positive sine of 40. B. Tan 323. Let's do a sketch. Let's write the cast rule. (323), what quadrant's that going to be in?
4.
Over here somewhere, right? So first of all, Sean, my friend, can you tell me, will the tangent of 323 be negative or positive? And how do you know?
Negative.
Yep. Which one would be positive? Cos. Or secant, but yeah, cos. Okay. Reference angle. Reference angle is this one here. How big? How do I find that one? 360 minus 323, which is 37. Double check me. No? Yes? Yeah? So, tan of 323 is the same as negative tan 37. Let's skip C. Let's skip D. Let's try E and F, and then I'll turn you loose. So E, 358 degrees. Oh, what's all the way around? So 358 degrees is going to be, oh, I forgot to write the cast rule. 358 degrees is going to be about there. There's the reference angle. What's the reference angle? This one you may be able to do in your head. 2, right? Because 3, not quite 360, 2 less than 360. So it's going to be the secant of 2 degrees. Will secant be positive or negative in that quadrant? What does secant go with? Cosine. Cosine, positive or negative? So secant, positive or negative? You know what? I'll put a plus sign there. You don't need, if you leave it blank, I'll include it's a plus sign. You guys see what we're doing? Get the hang of it? Now, I'm not going to do F. I'll just pause there, and I'll say, hey, what's your homework? And you got 15 minutes, which is kind of what I was aiming for. Absolutely, you need to practice this like crazy. So all of number 3, all of number 4, all of number 5, all of number 6. I may be assigning all of this. Let's see. Yeah, 7 is good. 8 is good. Yep, all of it. And I did attach the answers. Okay? Reference angles, hugely handy.